Way back, and I mean really way back, I designed a fuzz circuit, and it was published in a popular electronics magazine. It used these components, and it had some unique characteristics that I'd like to share with you. The first being that it used both an op amp, a 741, and a germanium transistor, which was very popular at the time. But look at the voltages. They're very unique for this type of circuit. In fact, it uses 3 AA batteries, and that allows both the op amp and the germanium transistor to saturate very easily and produce those nice warm fuzz tones. The only problem is it's very susceptible to noise, so it has to be in a shielded enclosure. And we're going to talk about building a shielded enclosure next. Here's the case I made. Notice the output and input jacks. Let me open it up for you so you can see the insides. First, we have the 3 AA batteries. We have the circuitry on the inside, and then we have the controls and of course the phono jacks. And you'll notice that the inside of the case is a bright copper color, and that's because I used this copper tape with conductive adhesive backing to completely cover the inside of the case and create a wonderful shield. Now the case itself is made of a common product, 1/8 inch thick tempered hardboard, and the case actually uses very little of this sheet, so you could make multiple things from that tempered hardboard in addition to the case. Let's start by cutting out 6 pieces for the front and rear, 2 pieces for the sides, and finally 2 pieces for the top and the bottom. When we have all of that cut, we'll take the 6 pieces and glue them together into 2 what I'd like to call super pieces, 3/8 of an inch thick each, one for the front and one for the rear. Then we'll take the sides and drill a hole for the phono jacks, and then glue the front and rear to the sides as shown here. And notice that the sides are taller than the front and rear, so we have to space them as shown. Once that case body has been glued and it has set, we can then take the top and drill the 4 holes shown here, put it onto the case body, and glue it onto the case body. The final piece that's left is the bottom, and we're not going to glue that on. We're going to screw that on later so that we have access to the inside of the case. We'll then paint everything as we'd like, and I created a nice decal. After the painting, I glued the decal onto the case top using spray adhesive. Now that the case is completed and ready to go, our next step is to create the circuitry on a solderless breadboard. And that's what we'll do now. So here's a standard solderless breadboard. Comes in various sizes. This is a 400-point solderless breadboard. It has an adhesive backing that's covered by a waxy piece of paper, and that adhesive backing actually can be taken off to the point where you can actually see the metal connections on the back, and we can roll that adhesive back and actually take off the buses on either side of the solderless breadboard, like that, to make it even smaller. Now what we really want to use in this project is something about this small. So once we've taken off the 2 buses, we can actually go to the point where we want to cut this into a section, take out those metal connections, and then cut that very easily with a hacksaw or any other type of saw. And that's what we're going to do. So let's get started building the circuit on the modified solderless breadboard. Here's the wiring diagram for the WayBack Fuzz, and notice we've cut down the solderless breadboard to 15 rows, meaning we've cut out at row 16, which leaves 15 rows left. So let's start by looking at the components. We have the 741 op amp right on the front, and notice the top is indicated by that little circle there. Next we have the germanium transistor 2N404. Then we have 6 resistors, a 1K, a 2 10Ks, a 47K, 100K, and a 2.2 meg resistor. We also have a 1 microfarad capacitor with its negative side going to H10. And we have 1, 2, 3, 4 jumpers to put in. And that will complete the circuit on the solderless breadboard. And now we have to complete the rest of the component hookup. And we can do that inside the case. Still referring to the wiring diagram, let's take a look at the components inside the case. First we have the 3 batteries, B3, B2, and B1, and notice that the grounds have been soldered to the copper foil. Moving on to the inside of the case, we have the S1, which is the stomp switch. We have the 2 phono jacks for input and output. We have the fuzz potentiometer. We have the volume potentiometer. We have the solderless breadboard, and we have the power switch. And note that I have the power switch as a double pole double throw here because that's what I had. You could also use a double pole single throw. Now it's a simple matter to take the case bottom, put it onto the case body, and secure everything together with 4 screws. And while I'm doing that, you'll notice that I've put 4 rubber feet onto the case bottom. There go the screws, and we're ready to try it out and do a little demo of the capabilities.